So welcome guys to the HopeConflict technology. Today we are going to solve the most frequently asked question in JEE exam. So the question is that 4 sin 2 theta plus 4 cosec 2 theta is equal to 7, and we have to find the value of tan theta. Okay, so these are the formulas that we require to solve these questions. Now we see all this formula during our solution. Okay, so now let's start with our solution. So here is our given equation is that the 4 sin 2 theta plus 4 cosec 2 theta is equal to 70. Now here we take the 4 as a common. So we got 4 in bracket of sin 2 theta plus cosec 2 theta is equal to 70. Now here we use the formula of cosec 2 theta. So what is meant by cosec 2 theta? The cosec 2 theta is equal to 1 by sin 2 theta. So apply this formula. So we got the 4 in bracket of sin 2 theta plus 1 by sin 2 theta. Okay, so guys, see here are two methods to solve this term. Okay, one is according to Bodmer's rule. You solve this bracket and got this term, or you can use your LCM method. Okay, this depend on totally you which method you use to solve this term. Okay, so because of the time limitation, we will continue with the Bodmer's rule. Okay, so after applying Bodmer's rule to this bracket and after solving this bracket, we got this term which is 4 in bracket square bracket in circular bracket sin square 2 theta plus 1 by sin 2 theta is equal to 70. Okay, simply we multiply this 4 to this bracket, so we got 4 sin square 2 theta plus 4 by sin 2 theta is equal to 70. Okay, so see here this sin 2 theta, this term is into the denominator. Okay, so we simply this transfer this term to the right hand side, so this denominator term convert to the multiplication. Okay, so after this we got sin square 2 theta plus 4 is equal to sin in bracket of sin 2 theta. Okay, so we simply multiply this 17 by sin 2 theta. Okay, so we got 4 sin square 2 theta plus 4 is equal to 17 sin 2 theta. Okay, as you know guys, if we have to solve this term, we require one quadratic equation. So for the quadratic equation, we simply transfer this term to the left hand side. So this positive term is converted into negative. So we got the quadratic equation which is 4 sin square 2 theta minus 17 sin 2 theta plus 4 is equal to 0. Okay, so we simply use here a splitting method. So we got 4 sin square 2 theta minus 16 sin 2 theta minus sin 2 theta plus 4 is equal to 0. Okay, so now here we take the 4 sin 2 theta as a common. So we got the 4 sin 2 theta in bracket sin 2 theta minus 4 minus 1 in bracket sin 2 theta minus 4 is equal to 0. Okay, so take the sin 2 theta minus 4 as a common. So we got the sin 2 theta minus 4 in another bracket 4 sin 2 theta minus 1 is equal to 0. So equating the both terms to the 0. So we got the sin 2 theta minus 4 is equal to 0, and here we got the 4 sin 2 theta minus 1 is equal to 0. So simply equating the sin 2 theta minus 4 is equal to the 0. So we got sin 2 theta minus 4 is equal to 0. Here we simply transfer this 4 to the right hand side. So we got sin 2 theta is equal to 4. But as we know that sin 2 theta is not equal to 4 because sin ratio lies in between the minus 1 and 1. Okay, so because of this rule, okay, we equating the 4 sin 2 theta minus 1 to the 0. Okay, so we got 4 sin 2 theta minus 1 is equal to 0 and 4 sin 2 theta. So after transferring this 1 to the right hand side, we got 4 sin 2 theta. Now, after simply transferring this 4 to the right hand side, we got the sin 2 theta is equal to 1 by 4. Okay, now guys, here you know that we have one more formula which is sin 2 theta is equal to 2 tan theta upon in bracket of 1 plus tan square theta. Okay, so simply apply this formula and put that value to the sin 2 theta. Okay, so we got one more term which is 2 tan theta upon 1 plus tan square theta is equal to 1 by 4. Okay, so here we use a simple cross multiplication method. So we got this new term which is 4 in bracket of 2 tan theta is equal to 1 in bracket of 1 plus tan square theta. Okay, here we simply multiply this 4 to this bracket and here we multiply 1 to this bracket. So we got one more new term which is 8 tan theta is equal to 1 plus tan square theta. Okay, so we got one more quadratic equation. For this we have to transfer this term to the right hand side. So we got one more quadratic equation. Okay, so simply transfer this term to the right hand side. So we got one more term which is tan square theta is minus 8 tan theta plus 1 is equal to 0. Okay, here you see that we are able to apply here quadratic formula. Okay, so simply apply the quadratic formula of tan theta and put the value of a, b, c okay, into this formula. Okay, now after putting this value into the formula, we got this term, and after simplification of this term, we got one more new term, which is 8 plus minus under root of 64 minus 4 upon 2. Okay, now simplify this term. Okay, now simplifying, after minusing the 4 from the 64, we got one more, which is 8 plus minus under root of 16 upon 2. Here you see that, guys, we do not able to take the under root of 16. Okay, so we have to split that number into the two number, which after splitting this number, we got a perfect square root of the number. Okay, so we simply split this 16 into the 15 into 4, so we take the perfect square root of the 4. Okay, now see, guys, here we got one more term after splitting this number into the 2, so 8 plus minus under root of 15 into 4 by 2. Okay, now here you know that we take the perfect square root of the 4, so take the square root of the 4, so we got 8 plus minus 2 under root of 15 by 2. Okay, now here you see that here is 8, here is the 2, and here is also 2, so we can able to take the common 2 from all these terms. So take 2 as a common, so we got 2 in bracket of 4 plus minus under root of 15 by 2. Okay, now these 2 and these 2 will get cancelled, so we got a final answer, which is 4 plus minus under root of 15. So here you see that our option, which is C and D, is correct. Okay, plus minus 4 plus minus under root of 15 is our final answer. Okay, so here is our final answer. If you have to solve this equation further, then you can continue. Okay, otherwise you can stop here. Okay, so thank you so much, guys.